All right. Everyone, thank you so much for joining us. If you have any issues with Zoom, please feel free to reach out to the panelists via the chat. Everyone is muted. But we're going to go ahead and get started. And for today's Graph Gurus 50. So this is our 50th episode of our webinar series for Graph. And today we're going to be talking about building a comprehensive data lineage solution with a graph database. So I'm going to cover some housekeeping items before we get started today. So as I said, if you need to reach us, please use the chat. But if you have questions regarding the content of the webinar, please use the Q&A. And at the end, we'll have time to go over those questions, but you can ask questions at any time. And we're recording the webinar today, and we'll email you with the slides and the recording and a bunch of other links. And then today, we are actually celebrating our 50th Graph Gurus episode with some prizes. So we will randomly select 5 attendees of the webinar today to get $50 gift cards. So I will go ahead and randomly select those after the webinar when we get the report, and then we'll email you with the names of the winners in a couple hours after the webinar today. So good luck with that, and I'll go ahead and pass it over to Rob, who is our host today.
Thanks, Emily. Hi, everyone. My name's Rob Horton. I've been in the business intelligence, database, and data warehousing industry for over 20 years. I've been at companies of various sizes, including IBM, SAP, and some other startups related to the industry, some that have been gobbled up by larger companies now. I've been with TigerGraph for a few months now, and graph database is really the most interesting technology I've learned in many years. It's a brand new way of looking at data and data modeling. It's been a very good exercise for my old brain to think about data modeling in a new way. It's quite different from my traditional relational third normal form way of thinking. Personally, I live near Cincinnati. I've got a large family. I could talk about them all day long, but let's get on to today's topic. So first, a little bit about graph. Benefits of graph database are becoming clearer to the mainstream. Everybody's kind of heard of graph now, and Gartner recognizes that forward-thinking organizations are differentiating themselves with the benefits that this technology brings. Specifically, a little bit about us at TigerGraph. We were founded in 2012 on the idea that graph databases could be easy to use and scalable for the enterprise without a dedicated army of programmers like the tech giants have. TigerGraph came out of stealth startup mode in 2017 and has since acquired Fortune 500 customers in banking, healthcare, telecom, media, as well as some innovative startups in cybersecurity and e-commerce. We've done this by providing the only natively distributed enterprise scalable graph database solution. At these companies, it's being used as a foundation for AI and ML type of applications, and can also be used for OLTP, OLAP, and other type of hybrid workloads. The GSQL language, it's easy to learn for SQL experienced folks, and it can also, TigerGraph can run on-premise in a VPC or as a fully managed service in any cloud environment. And let's talk about our topic a little bit. Let's start with Wikipedia for our definition of data lineage. While I wouldn't trust Wikipedia as a definitive source for everything, it's generally pretty good for tech industry topics, since tech industry professionals and experts take the time to make sure the info is accurate and up to date. Data lineage includes the data origin, what happens to it, and where it moves over time. Data lineage gives visibility while greatly simplifying the ability to trace errors back to the root cause in a data analytics process. Data lineage can be represented visually to discover the data flow and movement from source to definition via various changes and hops on its way in the enterprise environment. and how the data gets transformed along the way, how the representation and parameters change, and how the data can split or converge after each hop. The Wikipedia page actually for data lineage actually mentions graph database a few times. And I love this quote at the bottom: a simple representation of the data lineage can be shown with dots and lines, where dots represent a data container for data points, and lines connecting them represents the transformations the data point undergoes between the data and containers. This is almost the very definition of a graph database. So I think it's definitely a great fit. Why do we need data lineage? Most organizations got along just fine without it for a really long time. One reason is operational intelligence. In this case, that means having a quick understanding of the data pipelines in the organization. Visualizing the entire information flow landscape provides insight into who's using what and can answer questions such as what data sources feed the greatest number of downstream sources, or which data analysts use data that's ingested from a specific data source. It's also always a challenge to understand the semantics of business terminology when we talk about databases. Years ago, application development was usually isolated within a business function. So similar terms were usually used across different data models, since the same development team was probably doing all the work for a particular application. I spent my first several years in the business developing and supporting the very exciting application known as GLUS, G-L-U-S, which was the general ledger application for a large paper company. Now, during that time, we moved from a key punch system of input, tells you how long ago it was, into interactive screens. And since I supported both the old and the new systems, I tried to keep a consistency between the field names, between the old and new systems. However, the world is very different now. Most apps are not developed in-house anymore, and there's a much broader landscape of data. Data lineage allows data stewards to find common business terms, review their definitions, and clean up inconsistencies. Root cause analysis, and in this case, it's related to data incidents. So when a data consumer finds an error in the data, they probably don't have the ability to correct it right there, since the error likely occurred in an upstream process. Well, which process? That can be difficult to determine. Having insight into the data pipeline associated with particular transactions can narrow where a data problem occurred. You can then transition to finding why the error occurred and what actions are appropriate to correct the problem and prevent it from happening again in the future. The data landscape's always changing. In addition to regulatory requirements constantly evolving, internal business changes necessitate data changes, and ingested data source models can change unexpectedly. When there's a change in the environment, it's extremely valuable to assess the impacts over the entire enterprise application landscape. Data lineage provides a way to determine which downstream applications and processes are affected by and change and facilitates planning for the necessary updates. Across a global kind of cross-platform, cross-technology view of the data pipelines in a company can give you insight as to where the bottlenecks may occur. Maybe because there's a large number of incoming paths, and data lineage can kind of profile the execution times of various pipelines to maybe facilitate the redistribution of processing to relieve current and prevent future bottlenecks in your data flow. And finally, around auditability, data policies are implemented via business rules, and data lineage can be used to detect non-compliance of regulations such as BCBS 239, GDPR, and CCPA. So let's talk a little bit more about graph. Graph, what's different between that and a relational database? Graph analytics is a set of analytic techniques It allows for the exploration of relationships between entities of interest, such as organizations, people, transactions. In our case today, we'll talk about columns and BI reports and tables and load jobs and things like that, and the relationship between those. The application of graph processing and graph DBMSs is forecasted to grow at 100% annually, at least through 2022, as more companies accelerate their data preparation and enable more complex and adaptive data science. Graph data stores can efficiently model, explore, and query data with complex interrelationships across data silos, but the need for specialized skills has limited their adoption to big tech and specialized companies until recent years, and that's according to Gartner. Graph analytics will grow in the next few years due to the need to ask complex questions across complex data, which is not always practical or even possible at scale using SQL queries. So graph is good, but why is graph a better choice specifically for data lineage? Well, first and most obvious is that lineage data is highly connected. Analysis of it, it's all about connections. This alone makes it a great fit. A lineage depth is unknown and variable, meaning we don't know if tracing the lineage of a particular column will be a depth of 3 or a depth of 10. Uneven hierarchies are extremely difficult to manage in a relational database and very difficult to query. It's not impossible, but it's certainly not easy. TigerGraph's language of GSQL is designed for this type of query and doing the same kind of thing in PL SQL would be much more complex, and that would allow you to accomplish this with a relational database. And then finally, adding new types of nodes and edges is relatively easy to do with a graph database, and the sophistication of your data lineage can increase over time as you add more elements to your graph. So where do we get data lineage? So ETL tools like Informatica and DataStage can capture fine-grained or maybe more lazy information related to data load jobs, including what records, columns, and values are being added or updated at a particular point in time. So you not only get the general data flow paths from the ETL job definition, but you capture logs and lineage for specific data being updated. So in addition to database log CDC tools like HVR or Click, Kafka is also being used now to feed real-time change data capture information into data lineage platforms. BI tools like Tableau and Power BI can provide metadata about the columns and tables being used in a particular report or dashboard. A corporate data dictionary or data catalog that correlates business terms with database columns across databases that facilitates the understanding of data across the enterprise, whether it's a custom app generated by a database procedure, or if it's a sophisticated tool like Elation. All of these types of sources feed a comprehensive data lineage solution, and the interconnected nature of the data is a great fit for graph. So a few words about our demo we're going to get started with. Graph Studio is our web-based GUI for creating, loading, and exploring graphs. You see a few screenshots over to the right. It's not really designed to be a BI tool where you have thousands of business users logging into it. We have partners who do a great job of providing that type of technology. We're really just using Graph Studio to show our model and the types of queries that it facilitates. Graph Studio can show output as an interactive graph, which is mostly what we'll show today, but it can also output the data as JSON, which allows it to be exported and imported into any type of tool. And we've got lots of interfaces as well. So if you have want to do a RESTful API call, that's a very common way to interact with the back end of TigerGraph and put that into whatever front end visualization application you'd like. Because of the complexity of the connections of the data, of this data in particular, I've actually generated all the data by hand in a spreadsheet. Now, TigerGraph is designed to handle billions or even trillions of rows, but what we'll start today with is a small data set, but hopefully it will illustrate to you what's possible. And the instance that I'm running this on, it's just a Red Hat Linux instance up in AWS, and it's only 8 gigabytes of RAM and 40 gig of memory of disk space. So with this small data set, it still runs really fast, but this demo was not put together to show scalability and power, but to show how this type of data fits very well into a graph database model. So with that, let's jump into our demo. So as I said, we'll be conducting a demonstration from within Graph Studio, which provides the ability to design your graph brand new from scratch, as well as load data and explore the graph visually. We'll also see how we built some queries that might be very complex or like really repetitive. You'd have to run the same query over and over again with different parameters to accomplish that in a relational database. But it's actually quite simple to build and understand using TigerGraph. So let's first look at our model that we're using. One of the things I love about TigerGraph and graph models is that they're very self-documenting. We can look at this and really see the relationship between all these entities and how the data flows. So at the center of all this, we'll start with columns. So you see that over here, just database columns. Columns have business terms associated with them. Columns are sourced from other columns, in other databases, and we'll see how that flow looks as we go along. And columns belong to tables. Tables and columns are loaded by load jobs or processes. Columns are included in BI components like dashboards and reports. Along the top, load jobs are executed and complete at a particular timestamp. And particular table records are created or updated or deleted. And for each of those tables, individual columns are updated with particular values. Now we've got a few other vertices in our system, and a vertex is the kind of the entities here, kind of analogous to a table in a relational database, but a little different as well. So we've got a few other vertices that we won't focus too much on today, like BI system, user, system, and ETL. In a larger data set, those would serve to kind of group things, but for our purposes today, we won't hit those very much. All right, so in our case today, our graph is loaded from some CSV files that we generated in a spreadsheet for these use cases. In the real world, we'd have a variety of methods updating the graph, including real-time updates from something like Kafka, as well as probably batch updates from the output of ETL jobs and things like that. One important thing to point out on this screen is not only do we load the data into the vertices, the boxes with the names, but we also load data into the edges. The edges are the relationships between those. This is a primary difference between an edge in a graph database and a join in a relational database. A join is really just a suggestion for how to combine tables, and it's not really executed until query time. An edge in a graph database is populated at load time and actually contains values specified. So if I click on a few of these, you can see what I mean by how we map this. So there's This is a particular vertex or a node, we refer to it as sometimes, that's being loaded. And we can see how data is being mapped from our CSV file into our node. And same way, if we look at the edge, if I click there, data is actually being loaded into the edge data there, where we've got a particular record ID and a particular timestamp for when that was updated. So after we define how we're going to load the graph, which is what this whole exercise was, notice that one file here can be used to load multiple entities, multiple loads, and multiple vertices within the graph. We can actually load it. So if I go to the load data, it takes these CSV files, which have been staged up on my TigerGraph server. It actually loads those into the graph. So you can see over to the right that we've got almost 200 edges that we've created. None of our tables have over 20 records. And the factor between nodes and edges in a large database can be even bigger. Sometimes a graph with 1 million nodes or 1 million vertices can have 1 billion edges or more. So really the relationships count just as much as the records. So once our data is loaded, let me hit back a few times, kind of get back to where we start here. So once our data is loaded, we can explore the graph. And we can do that by looking at one or more different nodes. Let's choose to look at first maybe some business terms. So if I just click pick vertices here, it's going to pick from each and every one of these. And our graph will look like this when it comes back. It's not really useful. If we hover over it, we'll see the data that's represented there. But let's focus in on some of these. Let's unclick all and then choose instead business term. So now if I do pick vertices, it'll pull back up to 31 of those because I specified 31 over here. I can change my view of these a little bit and see it on a single screen arranged very nicely. And we'll do that several times as we're viewing as we go along here. So in this case, we've got these different business terms. So we're starting there kind of at the business view of our data pipeline. So one of the things I can do now is kind of navigate through this hierarchy, through just exploring through this. So if I double click on customer name here, what you'll see is that it opens up some other edges for me. Let me focus on this so it only is showing what I've selected, and let's change our view a little bit. So now it puts it on one screen there. So what we can see is this thing called customer name. If we hover over it, we see some things about that. We see that it's a format of a string of up to 50 characters, and the description is company, legal name, blah, blah, blah. So but what we see here is that these different columns are associated with that. So we've got from our Oracle order entry database, on the table called invoice, we've got something called customer company that's associated with that business term. Same way here with something from our accounts receivable database that's in DB2, we've got the customer name from there. In Salesforce, in the sales table, we've got something called customer info, or custom info table dot account name. So it's called account name over there. And over in Snowflake, we've got a relational cloud data warehouse where we've got some of our sales information, and that's in there. It's called just customer. So this ties together those different views, and now we can continue navigating through here. So let's click on one of these. Let's double click this one, the account ref. So when we click on that, let's do that same thing where we filtered our view And let's rearrange it so it's a little more readable. Now we see that for this thing that I clicked on, this customer name from the DB2 database, that it is sourced from something called, it's sourced from that Oracle column. They've got a common business term, which we saw before I kind of drilled down. This particular column is included in the report called receivables report. It's loaded by the nightly receivables load job, and it's part of the account ref table. So we're starting to see, how things tie together. So let's now look at this load job. Let's take a look at it. If I double click here, and we'll do the same thing that we did, we'll kind of filter this out just to get a few less things on the screen. And so now we see that for this particular load job, that it loads this table that we were just looking at called the account ref. It loads these three columns: customer name, invoice, and amount due. And this particular job has run twice, once on the 17th at 1:03 a.m. and again on the 25th at 20:24:57. Okay, hopefully that makes sense as we're navigating through this. So this load job in generic does these things, but specifically it loaded at these times. Let's go down another level. Let's look at this particular load job, this execution of it. And we can see that, let's just kind of expand this a little bit here, that these two particular records were updated. And if I hover over them, we can see what happens. So a particular record ID of 1235 was created in this particular run. In this case, we see it's record 1234 was created in that same run. And if I double click on one of these, I go down all the way to the column level. And let me focus in there and get a little better view. And we can see that for this particular record, it was updated by this particular job at this time, which we saw, but it includes these three columns. So it includes the customer name column with a value of BCD, the amount due with the value of 2,000, and the invoice number of 345. So we can see we started all the way at the business term, and we were able to quickly navigate just by clicking around, navigate all the way down to where that particular column was updated recently, on a particular load job. So we did it manually, kind of navigating this, but we can also operationalize this. So these types of queries will happen, can happen in a batch mode. They can be, set up interactively to perform certain functions. So let's go to the write queries option here. And what I've done is build some queries using the GSQL language that will do some of these navigations for us. So navigations that are fairly common with data lineage. So let's click on this first one. Now, when I click on it, it shows me all the source code over here on the right. So there's nothing magical or secret about it. But this particular query is going to take in as its input a particular column name. So the one I want to use for this is, I've got it in the comments here, so I can just copy it over. But when I click the run button, it gives me a place where I can key that in or copy and paste it. But what this one is going to do for a particular column, it's going to show the entire data lineage of that column. Now that may be a depth of 3, it might be a depth of 12. And it really varies by the data, because you never know how many steps along the way that a particular piece of data is going to go through. And that's a great fit and a great application of graph. So when I click run query here, it comes back and shows us very quickly, give a different view. So we entered as our input this snowflake sales DW. And notice that That one shows a little larger and kind of has a circle around it in our query. That's the thing we started with. And we can see that that particular column is sourced from this Oracle column. And that Oracle column is actually sourced from, ultimately, from Salesforce. So the account names, the customer names get entered initially into Salesforce, and those eventually feed into the invoicing system, and stuff from the invoicing system eventually feeds into the data warehouse. All right, let's look at a few more of these. This second one is just a data dictionary, and this one's pretty simple. If I just click run here, and let's use the example we had before, customer name, and click run query here. What this comes back was basically what we saw earlier, which was that these 4 columns are all really referred to as customer name. Ultimately, that's what they are. So we've got our one from Snowflake, Oracle, Salesforce, and accounts receivable. Another common use case for graph is impact analysis. Now, there's a couple different ways that we can go with this. And for this particular one, for a specified column, what I want to do is list all the BI reports that are directly connected to this, as well as any reports that are used in a downstream version of this column. So if I make a change to this column, well, it's easy. It's kind of easy to see what that's included in right away, but what's it going to be included? What downstream is included, and what reports might be affected there? So that's what we're going to run here. Let's pull in this particular column. We'll start at the Oracle invoicing column. So let's paste that in. And now when we do a run query, and let's shape this one like a circle, it shows it nicely. Let me make this a little bigger. Resize it. So we see our column that we started with in the middle here, this Oracle, invoice customer company, and we can see that it is included in these 2 reports. It's included in the open invoice report, and it's included in the current invoice report. And by the way, those reports also include this other column called quantity. I just decided to include that in this as well. But we can also see that this particular column sources the accounts receivable system version of that name, and it includes and that is included in the receivables report. Same way over here in Snowflake, this column sources the customer column in Snowflake, and this particular report called VP dashboard and this other one called daily sales are included there as well. And those also include another column called quantity sold. Okay, so that's kind of the reverse, or the first view of impact analysis. Let's look at it from the reverse view. So what if I have a particular report, and what I'd like to see for that report is not only the columns that are on that report, but what's the data lineage all the way back to the source for everything on that report. So let's run this one. We're going to use VP dashboard as our input there. So let's run this, include or copy it in. So now when we run this, let's take a force view of that. And what we see is that for this report, this VP dashboard report, it includes this quantity sold column, and it also includes this customer column. And for these 2 columns, here's their complete lineage. Snowflake comes from Oracle, which comes from Salesforce. And in this case, the Snowflake version comes from Oracle, where that information is entered initially. So it's kind of the view of, you can ultimately see where those numbers came from in, with this type of view. Now, if there were calculations included, we can include those here as well. And we can actually look at this in a JSON type of view. and we can see, okay, we're starting with this thing called VP dashboard and kind of connected to these two columns. And then we went a step further, and from those columns, we connected into their individual data lineages. So we're seeing all the information associated with that there. In addition to what we're showing, we could anything that's a part of that, like the calculation or how it's aggregated or how it's split up, during that transformation, we could include that here. Okay, great. So let's look at another common scenario. This one would be, let's look at a specified load job. See the recent executions associated with that and which columns and tables are updated by that. So let's start with this nightly receivables job. So when we run this, we just copy it in here. When we click run, let's update our view here. So we can see we have the load job at the middle. We can see that this particular load job has these three columns, and this is actually a view that we saw when we were exploring. So we can see that it comes back here visually, just like it did before. These columns, this table, and these individual executions of this job. So in addition to seeing it graphically like this, maybe it would make sense to see that in more of a JSON view, which then we could visualize however we'd like, or feed this data into another process for something to happen. But if I go back to the kind of interactive view here, I can, from this query that I ran, I can still drill down within that. So here are the records that were updated. If I click on one of these, I see the actual columns that were updated and the values associated with those. Okay, so this is kind of the change data capture view. And when you have an issue related to data, what you want is kind of instructions on how, maybe on what you need to back up or what data you need to update and where all does that need to flow to correct your situation. And you can see that here. It starts at a particular flow, but then you can easily take it to the the very source of where it needs to propagate to. I got one more that one of our engineers helped me put together, and this one's really just a search. So I could basically look for, if I'm interested in something that has been related to customer or whatever, I can enter a few characters of it, run a query, and it brings me back both from the column names and also from the business terms. It brings me back the information associated with those. So whether the matches associated with those. So then we could do something else with this data if we wanted. If I decided, okay, I want to go deeper on this one that I found, it'd be easy to do that. But again, this Graph Studio is really just designed as a developer's tool. It's not something that we would recommend deploying to 1,000 business users who don't get any training. That's there's another type of tool for visualization of this, but the back end of TigerGraph is really what will enable something like this at an enterprise scale. So with that, that's really what I wanted to show as part of the demo today. So let me go back to our slides here. So it's not a production implementation, but hopefully you can see that this the implementation of something like this is greatly simplified using graph database technology over some other type of data store. So with that, let's get into the QA session. I see that a few have come through, and I'll let my colleague Abhi address some of these questions. So one coming through in the Q&A is, what information needs to be fed to TigerGraph so that it can create the JSON files representing the graph? So really what we're just doing there is taking the column names and the values. That information is going to be in TigerGraph just from the from the design of the graph itself. So putting it out is very easy there. And the follow-up question to that is, does TigerGraph process any code or script written by the user from where that information is received? I'll let Abby help me
Yeah,
answer that.
sure. So, I would say a couple of things. So, what it takes to take the output out is in JSON format. As you were seeing, Rob was running the queries, and those queries were having some output printed, and that output, that query turns into a RESTful endpoint, and from those RESTful endpoints, you can access the JSON output, right? So that's pretty simple. In a simpler way, we have a REST APIs. If you look at docs.tigergraph.com, on the REST APIs, you can also access data related to also vertex related information. There are various different endpoints from handshakes and all those things which you can retrieve from TigerGraph server along with your data, vertex details, collections of vertices. You can run also interpreted queries whose data will come back to you in JSON format. So it's basically running your queries to get the data, get the output. The second part of the question is, does TigerGraph process any code or script written by the user from where the information is retrieved? Well, what you can do is that you can use our connector frameworks, and this connector framework will go and hit your servers to fetch the data. Right there, we have JDBC drivers and various different drivers. But in this case, since we are talking about the metadata information, I would say, have more like a loading job from TigerGraph side in which you can push the data. So rather than a pull, you can push the data inside TigerGraph. There are various different strategies we can adopt to address this question of yours. But again, this will require some sort of detailed conversation, how it is to be done. It's not a single answer I can give you on this. So, okay, so there is another question which says demo is great, but it is based on the loading of data from several CSV, which is not real world situation. That is true. What integrations are available to capture raw data sources across the big data ecosystem? So as I was mentioning in the earlier answers, we can come up with solutions in a way that you can stream this data through the Kafka pipelines. You can stream this data through into our RESTful APIs as the schema is designed. But when it's come to coming up with some sort of connectors that can hook into your Collibra or that can hook into your RDBMS just to fetch metadata, that is also something we can work with you on it. We have a JDBC driver, and it's an open source one, and we can tweak it in such a way that we can pull your metadata out rather than the data actually from that. Okay, so does the TigerGraph ship any meta model graph schema for the data lineage use case? Absolutely. So what I would suggest to you is that if you look at, so you will be given presentation, you will be given this recording. So this particular use case, what Rob was showing you, isn't available on our website. But if you reach out to us at rob@tigergraph.com or abi@tigergraph.com, we can send you the schema and you can run it on your side. But we have a starter kit. If you go to tgcloud.io, tgcloud.io, and over there you will have a one starter kit which is about data lineage, and you can try it out also. But if you need exactly what Rob was showing you today, I would suggest you to reach out to us on the emails which were provided.
I mean, eventually we could probably turn this into a starter kit as well.
Absolutely.
That would be available from TG Cloud. But yeah, if you're interested in seeing this model and just kind of evaluating it and adding to it or whatever, we can certainly make that available.
Absolutely, and it will take like a couple of weeks for us to put this as a starter kit, but we do plan to do that. Means the kit what we have isn't exactly the same. So another question is a really neat demo. That's a compliment for you, Rob. I'm just trying to grasp the amount of effort it would take to set up and what tools it could replace. Now, this is very interesting question, right? We are not giving you this as a solution for replacement of any tool. I mean, if you say, oh, can I replace Talend or Collibra or something of that sort, that's not the goal over here. That's for something you to decide. But what we are telling you is that based on your data lineage, maybe your master data management, data provenance, if you are having a problem over your data lakes or your bigger solutions where you may have hundreds of tables and columns which are highly interlinked together, and you need to do some deep link analytics to find out whether the column name like customer name and CNAME or these business terms are same, and you need to do some deeper level and intelligent level analytics on your data, then Graph is definitely a solution for you. Right? Means, of course, you can do all the basic flows what we were shown over here, but you can also do much more advanced work on top of this using the graph algorithm. So this is a deeper conversation, and I would suggest you to have a conversation with us that what is exactly what you are trying to do. Can you import data from other graph databases or other databases by connecting, or you need to get a pick from a flat files? No, not at all. You don't have to pick from a flat files. As I was telling, there are various different connectors. Do we pick from other graph databases? No, we don't have any connector for other graph databases. So what we would suggest is, what we know is one thing for sure, that every graph database can spit out its own schema and its own data in some sort of CSV format. So we will suggest that you put that into a flat file and import it into our system if you're planning to move from one system to another. Okay. Oh, another very good question. Maybe Rob, you want to take it. The question is it possible to know what dependency of variables, what is the dependency of a variable of interest? That is what variable it depends on. Means, can we do that kind of analysis?
So absolutely we could. That was not built into this demo, but if you think about it from a graph standpoint, this type of thing is very easy to add. You may or may not have dependencies in some cases, and you may have one dependency and you may have five. But using a graph database, it's easy to see those relationships and actually navigate those the same way we did from a sourced from information. You could kind of beef that up, and instead of being kind of a direct source with maybe just a formula associated with it, it could be multiple columns that it's coming from, or dependencies. So it's really kind of just a beefing up of the model that we started with here. Conceptually, that's something that's very easy to do within TigerGraph.
Great. And there is a very good question. And this question is from Dinesh, who says, how do we avoid misleading data lineage, especially when a query in a job has some decoded or translated value and use some alias name similar to actual column name? This is a very good question. And in fact, that is where the biggest value for graph databases will lie for you, especially when you're trying to do some higher level analytics or some kind of prediction or some kind of similarity on your data set. So this is an interesting conversation, Dinesh, we can have separately over email, but I can give you a very quick overview of this thing. As you were saying that your data set was connected to various different aspects. Let's say we're talking about a column which came from a table, and this table had multiple columns, and this has a specific name. Now, similarly, the name which is same for your alias or some translated name what you have will be coming from some database and table, and they will have many similar columns around it. So when you look at a table, there are many different columns, right? So similarly, your alias and your real value will have very similar names. So what kind of analysis you can do is not just based on the string matches and the proximity and the quality of the data set which is available to make this match, but also look at the proximity of this column, that how many other columns which are accessed along with this column has similar attributes and properties. So if you find out that a customer name is often accessed with social security number, followed by email, followed by phone number, and now you have an alias which has a very similar nature, you can conclude on your system saying that there is a 90% confidence that this basically is a same variable, is just an alias. So there are many interesting graph techniques you can apply, and that's a big value add that graph provides you on top of your current requirements. Okay, there are some good questions.
So Albi, I brought up the multi-graph slide because there's a couple of questions that I think would relate to that.
Sure, please go ahead.
So absolutely, there are a couple of those. One is, can we federate TigerGraph from different agencies? So not really a federation where you have multiple independent servers bringing those together into a federated graph. But what you can have is a large graph that is segmented, and data can be shared or not shared among agencies. So this is a nice graphic that would represent that, where we have one large graph, maybe with a product department, customer department, and IT department, and there's a certain amount of that they can all see, and there's a certain amount that only the particular applications can see, and then there's shared part between each of them. And so the idea here is that we can have just one copy of this. I don't have to replicate this graph to another server in order for product department to see part of it. You know, we can just make different parts of it available. It's all role-based access control, very, very easy to do this type of thing. So that addresses the federation, but also kind of Rajendra had a question about a very big graph databases. Can you break the graph databases into smaller parts? And I'm not sure if you mean by that the volume of data. In the case of TigerGraph, you would not need to break that into multiple servers, because TigerGraph has the ability to scale in an MPP type of way, where we can just have as many servers and nodes within our cluster as we need to support the amount of data. But in the case you're talking, you have lots of different types of nodes, lots of different types of edges, and you don't want to show that to everyone. This multi-graph would be the answer to that. Craig had a question about showing the links on the screen, but they're not hot. We will definitely include those in the email that goes out as a follow-up to this. So you'll get all the links there. For more detailed questions, my email is robb@tigergraph.com. Abhi is abhi@tigergraph.com. You can certainly reach out to either of us, and those addresses will also be in the email that we send out. And anonymous attendee, kind of the same thing there, trying to perform some data lineage on a model but got stuck. We'd be happy to discuss your requirements with you, so feel free to reach out to us offline. Another question from Rajendra. I'm not sure what the need to break the database. So as I mentioned before, the database can be broken down kind of logically, like we're showing on this particular slide, and breaking it down physically is not really needed for TigerGraph, but you can certainly have multiple instances, that are maybe providing failover for each other or something like that, where you have two that are running, they're identical. We can easily have some jobs to keep those in sync. TigerGraph has the ability to bring in real-time changes. You don't have to do it in a batch. Lots of customers of ours trickle data in, for an anti-money laundering type of or anti-fraud type of use case. It's really nice to be able to take, a new transaction that's just coming through and compare that to a graph of transactions that are related to that, to determine if there's anything shady going on. And to be able to do that in real time, you have to be able to do updates real time. So hopefully that answers that. Patrick had a question. I think Abhi addressed it before. Can you import, transform, export other graph models like Neo4j or Stardog with Graph Studio?
No, that's not something we do, or any of our competition does on our schema, as we are aware of. But what we will say is that if you can export the data in CSV format or flat files, you can import inside TigerGraph. And if this is about more like a graph models, have a conversation with us, ask question on our community. There may be some people who have expertise and put you in the right direction, or just reach out to us. Can we demonstrate? Of course not. That's not something which we have, so we can't demonstrate that to you. That's not really something we are eyeing also. But on the RDF front, means if you're talking about Stardog and you're looking only on the RDF structure of it, we can import inside RDF data inside TigerGraph. We also have a capacity in our beta version right now in which we can actually auto convert the RDF into a property graph model. So that's a very interesting thing, Patrick, if you want to try out. So, all right. So great. We got almost the time is up. And do you support PMML? Okay, there is one more question. Not yet, Patrick. This is not something which we support out of the box, but we'll be very happy to have conversation around it. If you have some specific needs, we can have detailed conversation around your data models and interchangeability. All right, over to you, Rob, for the closing statements.
Yeah, I don't know if Emily wants to address this last slide or not, but we've got a very large virtual event coming up in April. Anything else you want to say about that, Emily? Go ahead.
Yeah. It's free. Please register. We're going to send you a bunch of links in the email. And again, the winners of today's 5 prizes, but we welcome you to register for the Graph Plus AI Summit. And if you're interested in speaking, we have a call for speakers, and that actually closes, I think it's on Sunday. So if anyone is interested in speaking about their experiences with Graph Plus AI, please go ahead and check out our website. We have some amazing speakers, keynote speakers this year, JP Morgan Chase and Jaguar Land Rover, and we have analysts from Forrester speaking. So we hope you will join us on April 21st and 22nd. And then I think that is the last slide, but Rob, I think that there was a list of links. I think I need to actually update the other slide. So it says developer edition, it should be enterprise edition, but we have the cloud free edition, and we have the enterprise edition, which is also free. And you guys can go ahead and go to our website, and we will send you all the links from today.
Awesome. Thank you all for sticking around and for all the great questions. I can't wait to update this and make it even more relevant based upon your input. So I appreciate that very much.